Alright, so this is a follow-up video to the toolpath buildup we did when we made our toolpaths last time for this part. There's a few corrections that briefly need to be made to hopefully help fix some issues. So something that's really hard to see has to do with tooling parameters. So the rest of our facing and our adaptives, those are mostly correct, but there's one issue we run into when looking at our simulation and at our tool. So while we won't actually show a crash here, we will see that on its second pass, this tool cuts too low. So what's happening is when we get to the bottom part of the outside, unfortunately, the shoulder length, there is not enough shoulder length to clear, and the flute length is 0.75, this length is 0.85 inches. What that means is we're going to rub the wall of the tool that doesn't cut and doesn't clear against the outside of the part here. So originally when we did our toolpath, it said it had a 1-inch shoulder. But unfortunately that was incorrect, and we fixed that in that tool library. But what that means is that it was not correct. So the shoulder length is only 0.75. The shoulder length is the distance that can be next to the wall of the part and not rub. The flute length is the distance that can actually cut material. The length below holder is just how far the tool sticks out. So only our extended end mills have a shoulder length that is more than the flute length. In most cases, the flute length and the shoulder length are the same. This means we can only use this tool on the inside, and we have to choose a different tool for the outside. All of these radii here on these corners are only cut with the 3/8 tool, but on the outside, the rest of it can be cut with a larger tool. So we'll use a larger tool that gives us more flute length. So what we're going to do first of all is deselect that edge that we don't want to cut. So to fix this, I'm just going to click this selection and hit the trash can, and now we've just got the pockets we want to have cut. We'll do the same thing here, because once again it's too long for our tool, and we'll hit OK. Now we're only cutting what we can reach. Let's address another error that might have been missed. It says that the safe distance is higher than the retract height. So it automatically corrects this, but we can get rid of the warning just looking at the retract height and seeing that it's 0.2. We'll put our safe distance to 0.15, and now this error will disappear. Well, we want to do the same thing now. We want to take care of this outside edge. So we need to select a tool that can do that. We're going to do 2D adaptive, and this time we're going to go into our Cat 40 tool library. We're going to look for a flat end mill. Whereas we chose the Maximate, we're going to choose, that's the 3/8, we're going to choose the 1/2-inch Maximate in N2 aluminum. Alrighty. So this has been selected. We got to grab that outside edge just like we did before, but this is all that we want to cut. The heights we'll leave at default. We'll leave 0.02 axially or radially, but remember we're not supposed to leave anything axially, we don't need to. The tool is long enough, we don't need to choose multiple depths to cut, and the optimal load has already been set. So I'll hit OK, our toolpath will generate, and now we're just going to derive a 2D contour just like before. And I'm going to use the slotting feeds and speeds. It just slows it down to give a nice surface finish on the edge. We'll put this after our original two, and now we have our outside done, and there's going to be no collisions at all. We just added an extra tool. Another thing to be aware of is that distance we can tap downwards. We might not even want to go this far. The recommended tapping depth is at max 1.5 times the diameter of the tool. So what we'd say is from the whole top, edit expression, instead of 0.05, we can go minus 1.5 times tool underscore diameter. And that'll give us a better tapping distance. It's better representative of what we can actually reach. So it's pretty close, but it gives us a more safe tap. So those are all the corrections we want to make to those toolpaths to better adjust things for the tool we're using and the part and the clearances. And that's all we'll have to do.